Okay, this was always one of my favorite lessons because this is my favorite warm-up. I would write on the board, who wants a $20 bill? And then I would ask, okay, if you want this $20 bill, either give me the value of A or give me the value of B. And I would get 12 because 12 plus negative, and then someone else would choose negative 12, they add to 0. And y'all know that I wouldn't give you anything unless, of course, it was a sure thing. So I would pick some obscure numbers like A is 1 plus 7 square root of 3, and then B is negative 1 minus 7 square roots of 3, because when you add them, they zero out. So we'd spend a good, 4 or 5 minutes on this, and everybody would be so mad because they didn't get the $20 bill, because obviously I'm not going to give a $20 bill. Then I would say, okay, well, who wants a quarter? And we'd go through the same thing. And I would say, tell me what A is or tell me what B is. And I would make A whatever. I would make A equal 0. And I would let B equal whatever. Because think about it, no matter what B is, whenever you multiply 0 times a number, you'll always get 0. And this is our focus today. So you have the notes on solving equations by factoring. What I want to do now is go through them, okay? So here's how it works. If you look at AB equals 0, to get a product of 0, one of the numbers, I should say one of the factors, because oh goodness, Robadeer, that is what ties in to this unit. One of the factors must equal 0. So in this equation, either A equals 0 or B equals 0. You also have to consider where both may be 0. And we actually call this the zero product property. Okay? Now, we can actually use this for other things. So look at this equation. If I tell you that x times x plus 3 equals 0, one of these numbers must be 0. Either x equals 0 or x plus 3 equals 0. And oh my gosh, Robadeer, you just turned this into algebra. Yep, I did. So I would have two equations, either x equals 0 or x plus 3 equals 0. And in order to solve this, we would subtract the 3 from both sides, and we would find that x equals negative 3. So that's what we're going to work on now. So to solve an equation by factoring, you want to make sure the equation equals 0. You want to factor the expression, and then you want to set each factor equal to 0. Then solve, if necessary, to get all possible answers. And if you don't mind, I'm going to zoom in just a touch. Okay, so let's look here. I've got the equation 3r times r minus 4 equals 0. So what I do from here is I know that either 3r equals 0 or r minus 4 equals 0. So let's look at these one at a time. I'm going to cover that up for now. If 3r equals 0, I need to find what r is. How do we solve? Well, that's easy. You divide by 3 on both sides. So we get that r equals 0. Now I'm going to have this equation that's separate. I don't look at this anymore. I have that r minus 4 equals 0. What are we going to do to solve for r? We're going to add 4. And we're going to add the 4 to both sides. When we do that, we get that r equals 4. So my two solutions are 0 or 4. Plug it in and see. 3 times 0 is 0. 0 times whatever this is 0. So that one checks. Now let r equal 4. 3 times r is 12. 4 minus 4 is 0. What's 12 times 0? 0. Oh, that one also checks. All right, so this is what we're going to be doing. So let's look at number 2. I have that x minus 6 times x plus 4 equals 0. So I'm going to write this as two separate equations. Remember, if a product equals 0, each factor has to equal 0. So I know that either x minus 6 equals 0 or x plus 4 equals 0. So let's solve one at a time. We'll add 6 over here. We get that x equals 6. Or, to solve here for x, we're going to subtract the 4 from both sides. We get that x equals -4. So my two solutions are -4 and 6. Robadeer, why'd you write these this way, but you wrote it this way? Usually, when you report a solution, you're going to write it in increasing order or numerical order, whatever you want to call it. All right, let's look at number 3. Okay, number 3, I have x squared minus 6x equals 0. Okay, this one's a little different. Keep in mind, the property I'm using here is called the zero product property, not the zero difference property. So we've got to find a way to write this as multiplication. That is, we've got to find factors that make that. How do you make factors? You factor. So let's factor this. I have a greatest common factor of x. When I divide it out, I'm left with x minus 6. All right. Now it looks like example 1. So let's work through it. This means either x equals 0 or x minus 6 equals 0. So in order, this is already solved. That's nice. Now let's look at this one. In order for x minus 6 to equal 0, that means that x has to equal 6. So my solutions are 0 and 6. Okay, number 4. Holy summary of factoring, Batman. I have no idea how to do that. I don't see a greatest common factor. No, you don't see a greatest common factor, but I count 2 terms. This is a square, this is a square. That means this is a difference of squares. And when you factor a difference of squares, you get conjugates. So this is y plus 4 times y minus 4 equals 0. Sorry about that. So now we solve. Y plus 4 equals 0 or y minus 4 equals 0. So here we subtract the 4 from both sides. We get y is -4. Or here we add 4 to both sides. We get that y equals 4. So my solutions are -4 and 4. Again, we should check this. -4 squared is 16. 16 minus 16 is 0. That checks. 4 squared is 16. 16 minus 16 is 0. That checks as well. So we're good to go. All right, let's look at number 5. We have a squared plus 4a minus 21 equals 0. Okay, there's no common factor. There's no greatest common factor other than 1. There are 3 terms here, and I do see a trinomial, a quadratic trinomial. So that means we have to play product sum. Okay, so please give me 2 numbers with the product of -21 and a sum of 4. Those 2 numbers are, let's see, they have to be opposites. The bigger number is positive. So let's choose -3 and +7. So this factors to a minus 3 times a plus 7. So we set each individual factor equal to 0. Now we're going to add 3 to both sides over here. We get a equals 3, or we subtract over here and we get -7. So my possible solutions are -7 and 3. Again, I go from least to greatest. All right, what'd you think? That was nice, right? Okay, so now we're going to get a little crazier. Let's look here. Okay, I have 4y squared plus 10y plus 4 equals 0. What is always step number 1? Step number 1 is always look for a greatest common factor. And what is my greatest common factor? That would be 2. So when we factor out a 2, we're left with 2y squared plus 5y plus 2 equals 0. Okay, so now we have to look here. I'm going to go off to the side. 2y squared plus 5y plus 2. All right. What multiplies to 4? But at the same time adds to 5y? Well, let's start with 1y and 4y. Oh, ding, ding, ding. There it is. So this is, I'm going to put it in the box just to make my life easier for today. Okay, so we've got 4y squared plus 1y plus 4y plus 2. Okay, so that's how we broke this up. This was 2y squared plus 1y plus 4y plus 2. Okay, common factor here is 4y. Wait a minute, Robadeer, what are you doing? Oh my gosh, that's a 2. 2. Okay, common factor here is 2y. Common factor here is 1. Let's look in the rows. Common factor is y. Common factor is 2. Okay, so this factors to 2 times 2y plus 1 times y plus 2. So we know, now we have our 3 factors here, not just 2. I know that either 2 equals 0, or 2y plus 1 equals 0, or y plus 2 equals 0. Okay. Will 2 ever equal 0? Never. Never. Okay. Now let's look here. Either 2y plus 1 equals 0 or y plus 2 equals 0. So we'll solve here. 2y is negative 1, so y is negative 1/2. And we'll solve here. Y equals negative 2. So my solution set, the possible solutions will be negative 2 or negative 1/2. Okay? All right. And notice, here's what I want you to notice. See how this exponent is 2? That's how many solutions you should anticipate having at most. So we should have at most 2 solutions for that one. Okay, number 17, we deviate a little bit because we see that we don't equal 0. So guess what you got to do first? We need to move this over there. We need to 0 this out. So we're going to add it to both sides. So I'm going to do that, but I'm going to make sure this stays in decreasing order. So we get a squared plus 16a plus 64 equals 0. And here it's a plus 8 times a plus 8, because 8 and 8 are 2 numbers that multiply to 64 but add to 16. Now, I'm going to look at both of these, either a plus 8 equals 0 or a plus 8 equals 0, but guess what? I only have to solve one because they're the same thing. So here, there is only one solution. It's negative 8. And if we really want to get technical, we'll say the solution is negative 8, and it's a double root. That's a preview for when you get to Algebra 2. Okay, so keep that in mind. All right, now, this one's a little crazy. I've got 8x plus 33 equals x squared. All right. I can move the x squared over there, but then I have a negative x squared. And y'all flip out over any deviation. And you know what? I do too. I don't like to have a negative on that side. So I'm actually going to move these two over there because I do not want to factor any negative x squared anything. So I'm going to move this over. That'll 0 out. That'll 0 out. We'll get 0 equals x squared minus 8x minus 33. Okay? So, that doesn't help us. And you know what? I just realized that my notes were wrong. Oh my goodness. I'm going to have to go back and fix those. All right. Give me 2 numbers that multiply to make negative 33, but that add to negative 8. Those 2 numbers are negative 11 and positive 3. I mistakenly wrote 8 on the notes, and I apologize. So from here, I know that either x minus 11 equals 0 or x plus 3 equals 0. So we'll add 11 to both sides and get x equals 11, or we'll subtract 3 from both sides and we'll get x equals negative 3. So my solution is negative 3 or 11. All right, same thing happens here. Remember, this is the zero product property. So I need this thing to equal 0 somewhere. All right, let's move up. I'll put this here. That way you can still kind of see the above one because maybe you didn't see it. Oh, I'm having a moment. All right, now notice I don't like the negative there. I need to get rid of it. So to get rid of it, I need to add it. So I'm going to add here. I'm going to subtract here. I'm going to add there. So I put all this over here. And dang, if you don't combine like terms, life is going to be a little crazy. Okay, so this comes down as 3y squared. 7y minus y is 6y. Negative 1 plus 1 is 0. And all of that zeroes out. See this? This is so pretty. It's so simple. It looks like one of the easier problems on the front. So factoring, I have two terms. There's nothing there. Or there's no difference of squares. What's your first requirement or my first recommendation every time? Greatest common factor. The greatest common factor here is 3y. When I divide it out, I'm left with y plus 2. So from here, I know that 3y equals 0 or y plus 2 equals 0. To solve this, we divide by 3. We get that y equals 0. To solve this, we subtract 2. We get negative 2. So my solution is negative 2 or 0. Oh my gosh, and now we're on the last one. Remember, it's called the zero product property. I have a product property, but guess what? It ain't 0, it's negative 12. So I've got to do some craziness first. First, I need to FOIL. So we're going to get x squared plus x plus 8x plus 8, and that equals negative 12. So we get x squared plus 9x plus 8 equals negative 12. And now to make this side equal 0, we add the 12. We get x squared plus 9x plus 20. Okay, and y'all were geniuses at this now. So let's look at this. This becomes x plus 5 times x plus 4. Because 5 and 4 are two numbers that multiply to make 20, but that add to make 9. So I'm going to set each of these factors equal to 0. And then I solve. So on the left side, we subtract 5. We get x equals negative 5. Or we're going to subtract 4, and we get x equals negative 4. All right, so my solutions are negative 5 and negative 4. And guess what, kiddos? That's all you have to do for this. I'm doing the same thing every time. I'm just changing the numbers around, and that's what you're going to do. All right, that's it, guys. Have a good one.